radius R2 carries a uniform charge density rho. Gauss law, calculate the electric field distance R3. It is like a long wire. Since R is more than the radius, so it's outside the rod. So you need to go to the electric field for a long wire, what it will be. Using Gauss, what will be? Yeah, the outside. There is no other formula. It's only one formula for the electric field. But remember that now what you need is to find rho in the rho multiplied by the volume of the rod, which is equal. Let me share another cancel. This is why I ask is better. Let me tell you what. Yeah, long wire, but now it is not lambda because it's a rod. It is, you have to solve it by Gauss in different way, a little bit different. So what you do that E, let me write it down. Why is not working? E A equal Q enclosed over epsilon naught. What is E is the surface, which is 2 pi r small.
Surface of the Gauss, right?
Yes. Now, what is a Q enclosed? It is pi r square rho L. Rho by the volume.
Volume times the rho.
Epsilon.
Of the material.
Yes, of the, where is the charge is located. Then L with L go, and then you find now E out of it. Okay?
Okay, doctor. But the answer wasn't any one of them.
Cannot be. Okay, so maybe they made the mistakes and it's not there. And they fix it later.
As long as we understand the concept, yes.
All right, let's go back to your other question. Share. No. No. I'm sorry. Share application screen. What I need is this one. This is 1. This is 2. A positive charge Q is located at the center of an imaginary Gauss cube of side A. At the center, the flux of electric field through the surface of the cube is phi. Second, negative charge minus a Q is placed next to Q inside the cube. Which of the following statements will be true? The net electric field on the surface of the cube is equal to 0. So what is the wrong? Because the net charge inside the Gauss is 0.
If the Q's weren't the same, it won't be 0, right?
The electric field is 0 because the net charge inside Gauss 0. The electric field will be 0.
Yes, doctor. Okay, thank you. Next.
The figure below shows 2 arcs, circles, which plus, whatever. What is the electric potential of the circle? What do you think, simply?
I think it's 0, doctor.
Yeah, because it's symmetry. One is positive, one is negative. And both they are at the same distance, so you are looking. Integration. You have to do the integration. K dq over R, where dq is lambda dr. And lambda ds, and ds is 2 pi I'm sorry, it's r theta. Then it becomes as d theta. R d theta is my ds, and do the integration from 0 to 90 degree for the positive, and the other one put as a negative with whatever is the charge. And remember that Q is over the arc length, which is R pi over 2. Pi over 2. The figure below shows that the variation of the electric potential, okay, measured, okay, for which range of R is the magnitude of the electric field is largest. Now the derivative of the potential is my electric field. Here, how much is the slope? Is 4 over 2 in the region from 1 to 2 meter. Now from here to here, what is the slope? Is minus 4. Minus 4, that's minus 8 over 1. So that's in region what? From 2 to 4 is the maximum.
Then it rise over run?
From 4 to 6, 0. Because there's no variation in the voltage. From 2 to 4 is the maximum. So the answer is A. He's asking about magnitude.
دكتور ممكن توضحها
The
شلون؟
slope is large. Huh?
ممكن دكتور توضحها أكثر؟
Yeah, but the derivative is the slope of the line. Which has the greatest slope? It is from R equal to R to 4. Find the slope. Look to the slope. It's big. Is 8 over 2, that's 4. While the first rising one, the slope is 2. Delta y over delta x. You know the slope of a line. From 0 to 2, the slope is what? 4 over 2, that's meaning 2. From 2 to 4, the slope is what? Is minus 8 over 2, that's minus 4. So in magnitude is 4. So larger than the first one. From 4 to 6, 0, the slope, because it's potential does not change. So the right answer is A. The electron density in copper, we have 1 ampere wire with cross section, the electric drift velocity in meter per second with direction defined relative. It is exactly the same as we did there is example. The drift velocity meaning minus, it's opposite to the direction of the current. That's all. That's the meaning of the minus.
Can you repeat this, doctor? What is opposite to the current?
The motion of the electrons.
Okay, noted.
A small pulp is rated 7.5, operated 100. Tungsten filament had a temperature coefficient 410. When the filament is hot and the glowing, its temperature is 7 times the. So that's meaning that when it is operated, this is, you can find the resistance. How can you find the resistance? The one that you find it is 7.5 watt and 120 while it is glowing. So meaning it's in operation. Okay? So you need to find it at R0, which is at room temperature, which is 20 degrees. The temperature is 7 times, so meaning 7 times 120, that's 140. So this rate is 7.5 and 125 while it is in operation. It's not when it is on the shelf.
So we need to find R0 basically, not R.
Yes, that's asking to find R0, not R. This is what asking. What is the experiment at room temperature? Did you get it? Okay. Yeah, V square over R. I'm sorry, P equal IV or V square over R. The power is V square over R. Then you find the resistance. That's meaning what is R at 140 degree. A nickel wire is used in heating elements in a toaster. From the moment the toaster is first turned on to the moment the wire it reaches its maximum temperature, the current in the wire drops 20% from its initial value. What is the temperature change in the wire? The temperature coefficient of the is given. Wait a minute, let me enter the sun. I not to give the question directly, so I read it fast. So please let me read it again. Nickel wire is used as a heating element in a toaster. From the moment the toaster is first turned on to the moment the wire reaches its maximum temperature, the current, meaning the resistance increased. So the current dropped 20% of its initial. So how much it is now? 80%. So I final is 0.8. V is fixed, then R is what? It is 1 over 0.8 of its initial value. R is 1 over 0.8 of its initial value. Because the resistance increase, the current goes down. So how much it increase? The current, now it is 0.8. Like suppose the current was 10 ampere. Now it dropped to 20%, meaning 2 ampere. Now what is the new current is 8. The voltage 240. You divide it over 8, not over 10. Let's give you what? The resistance at that time. Okay? And this is, which is of R0. So 1 over 0.8 from R0, the initial one, which is at room temperature, which is 20 degrees. And then you calculate it, we'll find that how much is that value. All right. Okie dokie. Any other questions?
That's it from our side. And the column, what's it called for the coulombs? You know,
Yeah.
it's a device. It's something that rotates, which charges particles. I think it's a coulometer.
Colliders, you mean? Accelerators? Electrostatic? Oh, okay. You have like a rod and there is two piece of elements at the end. If you charge the top of the pin, then these will
Yes.
spray.
Yes, yes.
Yeah, because you transfer the same type of charge for the two metal ones. That's a charge detector, you can say. So both they are